Hello, today we're going to learn how to find all the roots of a polynomial equation. Remember that there are also terms that we can say zeros. So finding the zeros of a polynomial equation or the solutions of the polynomial equations would be the same thing as finding the roots of a polynomial equation. So there's three terms that I want to kind of refresh your memory on before we go through with some examples. The fundamental theorem of algebra, this states that the degree of a polynomial is the exact number of roots of that polynomial, including multiple and complex roots. So the degree of a polynomial, well, if we have a polynomial equation right here, so this is a function, the degree is the highest exponent of any of the terms. So here this is in standard form, the highest exponent here is 4. So this is 3x to the fourth. This is a fourth degree polynomial, meaning that we should have exactly four roots of this equation. Okay? So then the next term is multiple roots. Well, a multiple root is any root of a polynomial that appears more than once. So for example, we have out here to the side f of x equals x minus 2 quantity squared. So that means if we were trying to find the roots of this polynomial here, we would have x minus 2 showing up twice. Now remember, to solve for these quadratic equations, we would have to use the zero product property, set each of these factors equal to 0. Well, here x equals 2 is the 0 for both of these factors. So that means that x equals 2 is a multiple root of multiplicity of 2 because it shows up twice. So that's what a multiple root is. And lastly, we're talking about complex roots here, and that is any root that is a complex number. Well, a complex number, remember, is an imaginary number with a real number. So a plus bi is the form of a complex number. So we could have an example of, say, 1 plus 3i. Now, one thing to remember about complex roots is that they always travel in pairs. Remember, they're complex conjugates. So if 1 plus 3i is a root, we also know that 1 minus 3i is a root of that polynomial equation. Alright, let's look into the first equation here. So I want to find all the solutions to the polynomial equation x to the fifth minus x to the fourth minus 3x cubed plus 3x squared minus 4x plus 4. Here we're going to set that equal to 0. Now we always want to start off setting these equations equal to 0. Now notice we have a fifth degree polynomial. So how many terms or how many roots do you think we'll have? We should have 5 because this is 5. It's a fifth degree polynomial. Now the first thing that I would like to do, the first step in creating or finding the solution here is going to be to graph. Now this is pretty simple if you have your graphing calculator. So the first thing I want to do is graph using your calculators. Pardon my handwriting, I know it's ugly, but I think you'll get over that. Now, when we graph this, you can find all the rational roots fairly easy. So find all rational roots. Now, a rational root is just a root that is a rational number. And remember, rational numbers are any number that can be shown as a fraction or a whole number or a decimal that stops or repeats itself. Now, if I do this in the calculator, you should be able to find that you get roots or the x-intercepts. Remember, the root on a graph is the x-intercept of that polynomial. We should be able to find the roots 1, 2, and negative 2. Now, once I find this, notice that I've found 3 here, right? 1, 2, 3. I'm looking for 2 more because I need 5 roots total. So once I find my rational roots, I'm then going to use synthetic division to reduce this equation down to, and usually it's going to be able to reduce to a quadratic equation. There we can simplify it even further. So my second step is to use all rational roots to synthetically synthetically, there we go. That's, again, hard to read, but that's synthetically divide the polynomial. I'm going to try to write a little bit better from here on out. That looks like I'm in first grade still. Alright, so to synthetically divide this polynomial, I want to make sure I put all the coefficients down, and we need to make sure that each term is in descending order. And it does look like it is, so I'm going to have the coefficient of 1, -1, -3, +3, -4, and +4. Now, it doesn't matter which root you decide to use first, just as long as you use all the rational roots you found. Let's start with 1, since that's going to be the easiest. And remember, I bring down this number and bring it down to here first, okay? So I have the 1 down here, because that was brought down. Then I multiply the two numbers on the outside. So here's 1 times 1, and this is why I chose 1, because 1 times anything is going to be that number. So we're going to take this number and put it back up here. The product of these two is going to go right here. 1. Then we add these two together. So -1 plus 1 is 0. 0 times anything is 0. -3 plus 0 is -3. -3 times 1 is -3. We add the two together. 3 plus -3 is 0. 1 times 0 is 0. -4 plus 0 is -4. And then -4 times our 1 out in front is going to give me -4. And notice my last number is 0. Now remember that this is our remainder. We should always get a 0 for our remainder. If not, we need to go back and check our work. Maybe we did a multiplication or addition wrong in one of these steps. Or if we didn't, then that means that one of these is really not a 0. So now we got to go ahead and do this again. We have 3 zeros, so we're doing synthetic division 3 times. Here's the next one, 2. So I bring down the 1, and now I'm multiplying these by 2. So 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. Then I have -3 plus 4 is 1. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. -4 plus 4 is 0. Again, there's my remainder 0 that I'm looking for. One last time. This will be the third one. Now I'm multiplying everything down here by a -2. So I bring the 1 down again. 1 times the -2 is -2. 2 plus -2 will give me 0. 0 times -2 is 0. 1 plus 0 is 1. -2 times 1 is -2. And again, I get a remainder of 0. All of these are 0, so I'm doing pretty good now. Now the last step, once I've done this, is to solve. Now I can find the remaining roots. So the next step is to find any remaining roots by using either the quadratic formula or square root method. Now the square root method is a special case. This method requires that my b right here, my middle term, is 0. So now remember that these are the coefficients of my quadratic expression now. Since this is my remainder here, this is going to be my 1 is my constant, or c. My middle term is my b term, so that's my b is 0, so this is my bx term. And then this is going to be ax squared. So my a is 1, b is 0, c is 1. I could use those three in the quadratic formula, or I could use the square root method since my b is 0 here. So if I write my quadratic equation, I will have 1x squared plus 0x, which I don't need to write, plus 1 is equal to 0. Now, I can solve for my x squared. Subtract 1 from both sides. Get x squared equals -1, and then I square root both sides, And so the square root of x squared is just x. And the square root of -1 we know is I. Now when we take the square root of a number, we know that it's a complex root here. And so they travel in pairs. So its conjugate of I is also -I. So there's two solutions. We have a positive I and a negative I. Oops, don't want to cover that up. And then I don't want to forget the other three solutions I found up here, 1, 2, and -2. So I have, again, x equals 1, 2, and a -2. And there are my 5 solutions. Okay, here's another example that I would like for you guys to work on your own. And then I'm going to come back and show you how to do this. So we want to find all the solutions of this quadratic equation, or not quadratic, I'm sorry, polynomial equation. It's a 4th degree equation, and I want you to go ahead and solve this. If you get stuck, you can play the tape and then stop it once you get past the point where you're stuck. If you tried finishing the other equation, I think I may have made a mistake in it and written it down wrong. But here's the equation I would like for you to do, and I'll go ahead and explain this now. If you'd like to try to do this, go ahead and pause it on your own and then try to find the solutions and then press play again once you get them. So first we want to make sure that this is in standard form, so I am going to bring the 13x squared to the other side. So I do that by subtracting it, and then I'm going to add the 10x to both sides as well. Now this is a fairly lucky equation. Now we have to graph it and find all the x-intercepts. Now if we graph it, notice that this is a 4th degree polynomial. And you use your graphing calculator, you should see that it crosses the x-axis 4 times. Now using the trace function on your calculator, you can find that x is equal to -5, x is equal to 0, x is equal to 1, and x is equal to 2 as well. And we were able to find all of these roots just from looking at the graph itself and finding the x-intercepts. Notice that we have 1, 2, 3, 4 roots here, and that's exactly how many this one is going to have. So we don't have to go any further. Now real quick, I want to show you that we should be able to see that x equals 0 is a root very quickly, because each term has an x value in there. So if we had 0 in for x, 0 plus 2 times 0, anything times 0 is going to be 0. So we would have 0 is equal to 0. Every time that we have each term, including an x, having an x, we know x equals 0 will be a root. Okay, here is our next example that we're going to cover. Notice we have the polynomial equation f of x equals 2x cubed plus x squared plus 1. So again, first of all, we see that this is f of x and it's not already given that it's 0. So if we're trying to find the solution or the 0 of any polynomial equation, all we want to do is set this side equal to 0. So if we have f of x or y or g of x, let's just replace that with a 0. So we're going to have 0 equals 2x cubed plus x squared plus 1. And so now we want to find the x values that make this equation true for that equal to 0. And so again, yes, this is in standard form. So let's go ahead and plug this into our calculator, graph it. Once you graph it, you can see that there's only one x-intercept. So we have only one real 0. And we can see that it crosses the x-axis at -1. So there's our real 0. So that means that the other two, since we have 3, since this is a cubic function, a 3rd degree polynomial, we have three zeros of this polynomial. Here's 1, we're going to have 2 imaginary solutions or complex roots. So we're going to start off with synthetic division. So I'm going to put the coefficients. 2. Then we have 1 is the x, or the coefficient of x squared. And now notice that this is x cubed. If we subtract 1, it goes down to 2, so x squared. If we subtract 1, we should have an x value there, but we don't in this equation. So we need to have a placeholder when we're doing the synthetic division, and since we don't have an x term or a linear term, we're going to put a 0 in for that. And then our last term is always going to be the number of the constant. Well, here our constant is 1, so we have a 1. So remember that in synthetic division, if we skip a term, so x cubed, x squared, skip the x and go to the constant, we have to put a placeholder, and that placeholder is going to be 0. So now we are going to use -1 to synthetically divide, and so we bring down the 2, multiply it by -1, we get -2. Add these together, -1, multiply to the -1, I'm sorry, that's not -1, -1 times -1 should be a +1. Okay. 0 plus 1 is 1, then 1 times the -1 is going to be a -1 here, and that comes out good because our remainder is now 0. So now, we have a quadratic equation. Here's my c, my bx, or linear term, and then ax squared. So my a is 2, my b is -1, and c is a +1. I cannot use that square root method I did in the previous example because my b is not 0. So here I need to use the quadratic formula. If you remember, the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Tried to write neater, I think that's okay. Should be able to read that. So now I need to just plug in the values. Okay, so my first term is my opposite of b, or negative b. If my b is -1, the opposite is going to be a +1. So I have 1 plus or minus the square root of, and then b squared. So I have b is -1, so I have -1 squared minus 4 times a times c. Well, my a is 2, my c is 1, so I'm going to put a 2 and a 1 there. All over, or all divided by 2 times a, so I will have 2 times 2. Now let's simplify this. Everything inside this radical, and I'm going to go ahead and do this, make sure that your radical extends all the way past the last term. So -1 squared is +1, minus 4 times 2 times 1. 4 times 2 is 8, times 1 is still 8. So we have 1 minus 8 is going to be a -7. So I'm going to have 1 plus or minus the square root of -7 all over 4. 2 times 2 is 4. Okay, now we can simplify this further. 7 is not a perfect square, but we know that the square root of a negative number is going to have an I. That's an imaginary unit. So I'm going to bring that I out. And 1 plus or minus I, let me redo that one. I don't like the way that looks. I made a boo-boo. Alright, let's try this again. Equals 1 plus or minus the square root of -7 over 4. And then I'm going to bring that I out. So 1 plus or minus I, square roots of 7 all over 4. Now, if you can reduce, let's look at here. So I kind of call this the triangle. We need to be able to see if we can reduce all 3 of these numbers at once. Well, notice that here's a 1. We can't reduce 1 by anything, so that's not going to be able to happen. So these 3, we can't reduce anything here, and we also can't reduce the square root of 7, so that is completely reduced, and I made it again. Boo-boo. Okay, we're just going to repeat that. So 1 plus or minus I squared to 7, we know that that's all done for, so that's the reduced form of that. There's my 2 imaginary or complex roots, because it's 1 plus I squared to 7 and 1 minus I squared to 7 over 4. And then my 1 real root, so that gives me the 3 roots altogether that we know we will have. And we're done. Next, I want you guys to try to work on this problem. So we have g of x is equal to x cubed minus 5x squared plus 5x minus 4. And I want you guys to go ahead and work on that. Press pause for right now. Get as far as you can. Try to find the solutions. And then press play when you're ready to get the correct answer. Alright, here's the solution. So you graphed it in your calculator. You find that it crosses the x-axis one time at x equals 4. So there's our one real root. We know we're going to find two others because this is a cubic function, so we have three roots altogether. So now we're going to get ready for our synthetic division. So we have the coefficients of x cubed 1, -5, +5, and -4. Now check, make sure, do we need any zeros or placeholders? No, because it goes cubed, squared, x to the first, and a constant. So it does not skip a term. So now we're going to put 4 out in front, bring down the 1, and we're going to do this math. I'm going to do it pretty quick because I know you guys did this correct, right? For shizzle. So there's my simplification. So here's my c, my bx, and my ax squared term. So again, I need to use the quadratic formula because my b is not 0. So some of you guys, it would work or help you guys out to rewrite this every time you use this. It'll help remember it, and it'll help you with plugging in the numbers. So the opposite of b first, well, opposite of a -1 is +1, plus or minus the square root of b squared, so that's -1 squared, -4 times a, which is, +1, times c, which is also a +1. All over 2a, which is 2 times 1. Alright, so we go x equals 1 plus or minus, and we're going to reduce what's in the radical, and the denominator is just 2. So we have -1 squared is 1 minus 4 times 1 times 1. Well, that's pretty simple, that's 4. So 1 minus 4 is a -3. And again, we have a negative square root, so it's going to be I square roots of 3. And if we look, we cannot simplify any of this, the triangle right here, or we can't reduce that radical of 3. So this is our simplified version of the complex root, 1 plus or minus I squared to 3 divided by 4, which is 2 solutions, and our third is x equals 4. So in closing, we were able to learn how to find all roots of polynomial equations using synthetic division, our power of graphing, finding the roots or our rational roots by finding the x-intercepts, then synthetically divide that polynomial and using either the quadratic formula or the square root method. We were able to find all complex roots, rational and irrational roots.